Okay, now let's take a look at some examples. So if we want to evaluate 6 to the power of -2, remember, since our rule is that a to the power of n is negative n is 1 over a to the power of positive n, that means 6 to the power of -2 is 1 over 6 to the power of +2. And 6 to the power of +2 is, of course, 6 times 6, which is 36. So the answer is 1 over 36. Let's take a look at the next example. -4 to the power of -3. So notice here, -4 is in parentheses, which means that it's that whole number raised to the power of -3. Using our rule, it's the same thing as saying 1 over -4 to the power of +3. Well, that's 1 over -4 times -4 times -4. Since we are multiplying negative by negative by negative, our answer is negative. And 4 times 4 is 16. 16 times 4 is 64. So the answer is negative 1 over 64. Let's take a look at example 3. 1 over 2 to the power of -5. So I am going to do this problem two ways. First, I'll do it the slightly longer way, and then I'll show you how I would like for you to think about it more efficiently. So 1 over 2 to the power of -5 is 1 over. Now 2 to the power of -5 is 1 over 2 to the power of +5 according to our rule. Two to the power of 5 is 2 times 2 times 2 times 2 times 2, and 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16, and 16 times 2 is 32. So that's 1 over 32. But what does this mean? What is 1 over 32? Well, remember that this fraction bar means division. That's like saying 1 divided by 1 over 32. And when we divide by a fraction, that's multiplying by the reciprocal, right? We flip the second fraction and multiply. And 1 times 32 over 1, of course, is just 32. So this would be the long way of doing it, right? We first figure out what 2 to the -5 is, and then we divide 1 by that number. But let's think about what happened if we hijack the problem after the first step. Isn't this 1 over 1 to the 2 to the 5th the same thing as 1 divided by 1 over 2 to the 5th? And then if we flip, isn't that just 1 times 2 to the 5th, which we now know is 32? Basically, all we had to do is take this 2 to the 5th, move it into the numerator, and make that exponent of 5 positive. That's kind of the shortcut that you can use here, and you'll see me use in future examples. So let's if you're ever confused about why the shortcut works, you can always rewrite everything the long way, and then when you get to the division part, you'll see, oh yes, of course, we flip the fraction, that's why it goes to the top. Let's take a look at example 4. So 6 is not raised to a negative power, so 6 stays in the numerator. 3 to the power of negative 2, however, is raised to a negative power, so we're going to move it into the numerator, and the exponent becomes positive. We could say over 1 if you want to leave something in the denominator, but that's not very necessary. Now remember, order of operations, we can't multiply the 6 by the 3 because exponents come first. 3 to the second power, 3 times 3 is 9, and 6 times 9 is 54, so the answer is 54. Next example, 10 to the negative 3 over 25. So here we have a little bit of a reverse situation. Now the number raised to the negative power is on the top, and the shortcut is to move it to the bottom and make the exponent negative. Just like if it was on the bottom, you move it to the top and make the exponent positive, because that's how reciprocals work. You just move the top to the bottom. So remember, it's not like there's nothing left when the 10 is moved, because you can always say this is multiplied by 1. So there's still a 1 left over. 25 stays on the bottom. It's not raised to a negative power, so it doesn't get to move. Times 10 to the power of positive 3. Well, again, exponents come first. 10 to the power of 3 is 1,000, so that's 25 times 1,000, which is 25,000. So the answer is 1 over 25,000. If you're still a little bit confused about why this 10 to the negative 3 should move down as 10 to the positive 3, remember that what we basically have when we have any fraction a over b, it's the same thing as saying a over 1 times 1 over b. We can always separate the numerator and the denominator. So 10 to the negative 3 over 1 times 1 over 25. And as you can see, the 10 to the negative 3, that part becomes 1 over 10 to the positive 3. And that's why the 10 to the third moves to the bottom. Okay, one more example to really illustrate this point, to really illustrate this shortcut of being able to take a negative exponent and move it to make it positive. 3 times 2 to the negative third over 4 to the negative second times 7 to the positive second. Notice that 2 to the negative third is a number raised to a negative power. 4 to the negative second is a number that's raised to a negative power. But 3 and 7 are not raised to any negative power, so those don't have to move. The 3 will still stay on top. The 7 squared will stay on the bottom. It's just that the 4 to the negative second goes to the numerator to become 4 to the positive second, and 2 to the negative third becomes 2 to the positive third by moving down, right? It's those numbers that are raised to the negative power that we move and change the exponents. And now we are ready to multiply. From here, I'll show you how to do the problem 2 ways. Well, not maybe 2 ways. I'll do it 1 way, but I'll illustrate what you can do. So 3 times 4 squared is 16 over 7 squared, which is 49, times 2 cubed, which is 8. Now you could multiply at this point and say 3 times 16 is 48. You could multiply 49 by 8, and that would be 392, I believe. Right? You can do all of this, and then try to simplify 48 over 392. That seems like a bit of a pain. It's much easier before you even do the multiplying to just say, oh, 16 and 8 can both be divided by 8, becoming a 2 and a 1. And now we're left with 3 times 2, which is 6, over 49 times 1, which is 49. It's an easier way to go.